Okay, welcome ladies and gentlemen. So what we have now is we've got a worksheet that you were working on and explain what effect each of the following transformations have on the graph y equals x squared. So we'll notice that this is the a part. Remember, we're dealing with y equals a, x plus h squared plus k. And the a value is going to deal with vertical stretches, compressions, and reflections. So this 7 is going to give you a vertical stretch by a multiple of 7. And what that means is the step pattern is going to be different. If I was to go over 1, I would go up 1 squared times 7. If I go over 2, I would go up 2 squared times 7. So that's going to be a vertical stretch. We see here we have an a value again, so that's going to affect the y values. But in this case, we're only going to take a third of whatever we normally would take. So if we normally go over 1 and up 1 squared, we're going to go over 1, up 1/3 of 1. And if we would normally go over 2 and up 2 squared, which is 4, we're going to go over 2 and only go up 1/3 of 4. We're going to take that 4 and divide it by 3. So this is going to result in a vertical compression by a multiple of 1/3. Some people will say it's a vertical compression of 3. I prefer a multiple of 1/3. We have two things going on here. We have a negative and we have the number. So the negative is going to be a reflection in the x-axis. So that's actually going to make this open down. And the 26 is going to be a vertical stretch by a multiple of 26, which means that it's going to be skinnier than y equals x squared, but it's also going to open down. Let's see what's going on over here. So we've got a 20. That's a vertical stretch. And then we've got the negative 17 on the inside. And then you've got a shift horizontally, 17 units right. Over here, we have a reflection in x-axis. You have a shift left horizontally, 100. And you have a shift down 33 units. And the last one here, we have a vertical compression by 7, if you will, or a multiple of 1/7. You have a shift right 20 units, and you have a shift up 14. Okay, on to number 2. Write an equation that has undergone the following transformations, and we're going to take it from the y equals x squared. So if I'm just going to have a compression of 7, it will be 1 over 7x squared. It could have other things, but right now they wanted me to show that I know how to get a compression of 7, so it's 1 divided by 7. I need a reflection. I need a stretch. I need a shift. I need a shift. Interesting. I'm going to start with a shift. I'm going to start with the shift left, so it's x plus 19. So that's a shift to the left 19. I'm going to put in my shift down 28. I'm going to put in my stretch, and I'm going to put in the reflection. And notice I did it starting from here. It's just easier that way. So I need a reflection, a compression, and up. So I'm going to start off with my reflection and my compression. That is my reflection, my compression to x squared, and up 90. Graph each of the following. State your vertex, your step pattern, and blah, blah, blah. So this is a fairly straightforward one, 9x squared. So it's a vertical stretch, which means that my vertex doesn't change. It's still going to be 0, 0. My step pattern is over x up 9x squared. Because of the 9, it's a vertical stretch. My y-intercept can be found easily if I set x equals to 0. Get 0 here, 0 squared is 0, times 9 is 0, so my y-intercept is 0. My x-intercept, if I set y equal to 0, the only values of x that will give me a 0 on this side is also 0. It opens up, so I'm going to have a minimum, and the minimum is going to come from my vertex, and it's going to be 0. So I did all of that without even graphing it. This is what it looks like as a graph. Vertex is 0, 0. Over 1, up 9. After that, it goes off the grid. You can see that my x-intercept is 0, my y-intercept is 0, and I have a minimum value of 0. Flip over. We have a number of things happening here. We have a reflection, a compression, a shift to the left, and a shift up. The shift left and the shift up are going to affect my vertex. To the left and up. The step pattern is going to be affected by the a value. So it's going to be over x, and it's going to be down, because of the negative, 1/2 x squared. The y-intercept, if I set x equals to 0, putting in 0 here, 4 squared is 16, divided by 2 is 8, negative is negative 8, plus 2 should be negative 6. So my y-intercept should be right here. My vertex should be negative 4, 2. My x-intercept, that's too hard to figure out with our mathematics. If I set this equal to 0, that's a hard equation to solve. So I'm going to leave that and graph it to be able to tell. Max or min, it opens down. So that means that it's a max. And its maximum value comes from the vertex. It's going to be a maximum value of 2. So my step pattern, over x, down x squared divided by 2. So over 1, down 1/2. Over 1, down 1/2. Over 2, down 2. Over 2, down 2. Over 3, down 4.5. 1, 2, 3, 4.5. 4.5. Over 4, 1, 2, 3, 4. I should be down 16 divided by 2. I should be down 8. 1, 2, 3, 4, 5, 6, 7, 8. It worked. I can now read my x values for my x-intercept. They're going to be negative 2 and negative 6. I can check them with the equation. If I take negative 6, plug it in, negative 6 plus 4 is negative 2, negative 2 squared is 4, divided by 2 is 2, negative 2 plus 2 is 0. So negative 6 will give me a y value of 0, which is in fact an x-intercept, negative 6, 0. What if I plugged in negative 2? Negative 2 plus 4 is 2, 2 squared is 4, divided by 2 is 2, negative 2 plus 2 is 0. So this point also is a y-intercept. We're done. Next one. We have a vertical stretch, we have a shift to the right 3, and a shift down 8. That's going to change my vertex. 3, negative 8. Positive 3 because it's movement to the right. 1, 2, 3, down negative 6, negative 7, negative 8. That's my vertex. 3, negative 8. Step pattern. That's going to be affected by the 2. So it's going to be over x up 2x squared. So over 1 up 1 times 2. So over 1 up 2. Over 1 up 2. Over 2 up 4 normally, but it's multiplied by 2, so it's up 8. 1, 2, 3, 4, 5, 6, 7, 8. 8. Over 3 up 9 normally, but it's going to be 9 times 2 is 18. So, and we have the parabola. What's its y-intercept? It looks like 10. I took that from the graph. Let's check. If I put in 0 for x, it'll be negative 3 squared, which is 9. 9 times 2 is 18. 18 subtract 8 is 10. X-intercepts looks like it should be 5 and 1. Let's check. Put in 1. 1 take away 3 is negative 2. Negative 2 squared is 4. Times 2 is 8. 8 subtract 8 is 0. That one works. 5. 5 subtract 3 is 2. 2 squared is 4. 4 times 2 is 8. It works. It opens up, so it's going to be a minimum. And the minimum value is negative 8, which again, you can see from the vertex. Last one on this sheet. We have a negative, which is a reflection. We have a shift to the right and a shift up 9. So my vertex is 4, 9. 4, 9. It's going to open down, so it's going to come down this way. My step pattern is over 1, now so over x in general. And notice there's no a value other than a 1 here. It's a negative 1. So it's not going to be stretched or compressed. It's just going to be reflected. So instead of going up x squared, we're going to go down x squared. Y-intercept. I can determine this by setting x equals to 0. Negative 4 squared is 16. Negative 16 plus 9 should be negative 7. X-intercepts, I'm going to have to wait till I graph it. Max or min, I know it opens down. So it's got to be a max. And that maximum will be the 9. Let's graph it. Here's my vertex. Over 1, down 1 squared. Over 2, down 2 squared. 1, 2, 3, 4. 1, 2, 3, 4. Over 3, 1, 2, 3, down 9. Over 4, down 16. I think that's right. I better count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It is. And so what is this value? This is negative 5, negative 6, negative 7. So look, there's my y-intercept, negative 7. And here's my parabola. What are my x-intercepts? Well, it looks like it's 1 and 7. Let's make sure. Plug in 1. Negative 3 squared is 9. Negative 9 plus 9 is 0. 7. Subtract 4 is 3. 3 squared is 9. And again, we get 0. So this is grand. Everything is good, and that's the end of that sheet. Make sure that you can do this work because you're going to be tested and quizzed on questions like this.